Well, now we're going to jump into displays for a quantitative variable. Earlier talked about categorical variables, but let's start talking about histograms first for quantitative. So students have now looked at bar charts and pie charts and the differences between those two and when you would use one over the other. So it's important now that they understand the difference between bar charts and histograms. So we start off by showing them one of each in a workbook page because they kind of look a little bit alike each other. And so they look at two of them and they say, they notice and wonder, like, what's the same about them and what's different, and let them in their discovery mode kind of look at some things. So lead them to kind of say, you'll hear the kids say, well, they both have bars. Yeah, they do. They both count something, frequency of something. Oh, they both have axes like X and Y count, in the chart, but we start looking at them, on the bar chart side, the little differences there is that, we start thinking about this. Bars there, could they be ordered any way we wanted? Sure. If I move dog and cat places, like right now they're in alphabetical order, but if they weren't, would it still make sense to me? Would I be able to analyze how many dogs, cats, and rabbits were in the shelter easily? Yeah, it really wouldn't confuse the situation. And there's also, in a bar chart, definitely space between the bars to show these discrete, this very is a non-continuous type of variable, right? However, when you get to the quantitative variable, now you see, well, I really wouldn't want to reorder those bars and put 30 to 40 pounds before 0 to 10 and put them in that order. My brain would go, it's a little bit confusing. So we wouldn't want to do that. The shape of that data, what it shows, and we're going to get later into talking more about that, a histogram does show the shape of the quantitative variable. The bars touch in this, and I know the Google graph has a little bit of a gap there, but it typically this means they are right next to each other, just showing the continuous flow of our data. There's really no space. But bottom line, the students need to come up with and see, bar charts are for categorical variables and histograms are for those quantitative variables. I could see that there, that cat, dog, rabbit species is a categorical variable, whereas pounds was that quantitative variable. Okay. And with all of our graphs, we like for students to build them by hand first, on paper first, before they go to the computer, so that they have a deeper understanding of what the graph is doing. And so it's showing the students, well, if you had to build a histogram, what would you do? Well, you need to take your data and you should order it from least to greatest. You would subtract your minimum from your maximum so you could see what your range is of your data. Divide that by 10, basically. That's a good, easy place to start because most of us can divide by 10 and get a good idea in our head. And then use that to be that bin size, which they will understand and learn more about later, and mark off the x-axis, if you will, the horizontal axis with that bin size, count by that number. So if you had done 20 divided by, or 200 divided by 10 and got bin size of 20, count 20, 40, 60, 80 across. And then the height of the bar would then be the count of the values in that bin. So how many values would go from 0 to 20 and make the bar that height. Okay? And so we would take them to a worksheet where they would do that and make one by hand. But the next thing that they would do is get a discovery point. Well, how would I know what the right bin size is? Because that's another thing to learn how to do. Really important, because that's where we're showing the shape. And here's an example in the workbook page where they're working the right bin size. Oops, sorry about that. We got this covered here, that this label in a histogram in the contract, it asks you to give the table name, a label, and then the column name that you want to graph, and then the bin size. Okay, so let's get out of this for a second and go to that workbook page where you can see the contract, histogram, table, string, and it tells them labels, column name, and bin size to get this image, right? So here's that they're going to practice on. They're going to go make some, and in that discovery mode, they're going to try a few different bin sizes and begin to say, which one is the better one? Well, what do we mean by better? Well, if I made my bin size 10, I see here that a whole bunch of the animals weigh between 0 and 10 pounds. Like, okay, duh. That doesn't really tell me a whole lot about them. Okay, but let's go back to this label for a minute. What is that label? That label, we made a name on this workbook page. It told us to do that. And we can see here, if I hover in the interactive mode on the graph, I see Buddy comes up, the name of the animal. So as I hover over each of these squares, it comes up, or rectangles here, right? The name of the animal will come up in interactive mode, so I could see it there, okay? And the value of that particular, how many weeks that particular animal took. But over here, we change it to 2, and there's that label, Cujo. See, Cujo took 30 weeks to be adopted. And this one tells me a little bit more. I still see the shape of that data, but now I see some gaps in here, and I could see a whole lot more clarity about the 2, 4, 6, 8, 10 weeks, and I can sure see a lot more clarity, granularity, if you will, about what's going on. Okay, so bottom line is, as they work, they're going to figure out, and they're going to then have a conversation of what they think was the best bin size, have them talk about that. They want to be able to see a good bin size. Will let them see those outliers out there. We could see that there's some heavier animals, animals that took longer to be adopted out here, but we're not sure how long and what was going on out here with those last 3. Here we can see exactly how long those last 3 took, within two weeks, right? Getting closer to that. Okay. So that gives us a little bit better idea of what's going on with the extreme values. A little bit of warning as you're getting the students to really say, here's a great way to get your bin size. They're going to come with the rule of thumb is 5 to 10 bins will be what's good. But remember, it's a rule of thumb. You want to say, what are you going to do to tell your story the best? You want to be telling the story. You have a question you want to answer. Which one of these best answers your question that you're trying to answer on your data? So, think that through. And then you get them to that point, and they say, oh, I need my bin size to be 7. And they put in a 7, and when they put that in Pirate, it'll come back as bin size 5. Within Google, there are defaults, and I just put this down here. You'll see that there are several defaults. It rounds it to the nearest one. You could get size 1, 2, 5, 10, 20, and just be aware of that when the students start saying something about it doesn't do 7, it doesn't do 8, it doesn't do 9. It just rounds it to the nearest. So just tell them, hey, go figure out which one of those that it rounds to tells your story the best. It's just one of those things within Google that we, as they make the graph, it will round it to. They don't do every single number. But if we were doing it by hand, we could have done it that way. Okay. Right. Just a little bit more when they're done learning then about how to make them and how to find the right bin size. Now let's apply it so they can go in and make their own chosen data set now. Go to the data cycle workbook page, come up with a good question for their histogram. What's a good histogram question? Get some histograms made within their own data sets and apply it. We also have out there Desmos activities. There's one for exploring the bin size, and then we now have checkpoints, which you could use for assessments, and I will show you just a second on that. There's also, you could combine these checkpoints for a full assessment. And so just real quickly, here is the Desmos activity on bin size that they could play with. They could move around that bin size and say, which one tells the story the best? Oh man, if I make my bin size really big, that I lose the story, I lose the granularity. If I make it too small, then it's like, you know, that's too many to really, you know. Yeah, so they start figuring out what bin size would be the best to get an idea of the shape without going too granular. Here's the assessments that we have now out there. They have Desmos, there's questions, and you can take them as checkpoints throughout the learning, or save it to the end for one final formal assessment. Pretty cool. Yeah? Now, there's videos on shape and how to connect histograms to box plots, so you're going to want to go check those out as well.